So this is question 12 from class activity 5 from the sapling. And what it asks is, it says that 2-methylbutane is a compound containing a branch carbon chain, and it looks like this. Okay, and then it's asking you to look down the C2-C3 bond. So that is going to be this bond right here. Okay, let's do that in green instead, but you get the right idea. And so if you're looking at this, if you're going to build a model, your eye, there's your eyeball, looking down that bond. And so here, what you have, here you have all the possible conformers of the 2-methylbutane. And here you have a basically a potential energy diagram, and just like the ones that we saw when we looked at butane and ethane in class activity 5A. And what they're asking you to do is to put all of these different conformers in the right box. So the first thing to recognize is that all of the lower energy conformations, all the minimums, these are all going to represent staggered conformations. And then all of these higher energy conformations are all going to represent eclipsed conformations. All the conformations are not the same energy. All the staggered conformations are not the same energy, because in the staggered conformations you can have gauche interactions, and that can raise the energy slightly. All of the eclipsed conformations aren't going to be the same in potential energy either, because in some eclipsed conformations you're going to have 2 methyl groups interacting, and in some eclipsed conformations you're going to have methyl groups interacting with hydrogens. So if you imagine building a model of this, if you look at all the different conformers, what you can see is they basically took the front carbon and kept it in the same orientation. So that's this carbon, or the 2 carbon. They kept it in the same orientation, and then this back carbon, 3, basically they rotated it. And that's the different, that rotation, that angle of rotation gives you all the different conformers that have all the different potential energies. So hopefully you built a model for your 2-methylbutane, and you, as I said, you rotated this back carbon and kept the front carbon still. And so here are the answers, and what I'm going to do is I'm going to go and point out the different interactions in each of. First, I'm going to do each of the staggered conformers. So for A and E, for each of those, you have one gauche interaction that I've marked with a G there. And for conformer C, you've got 2 gauche interactions, and that's why C is slightly higher in potential energy than A or E. But notice they're all staggered conformations. For the eclipsed conformations, notice that in B and D, in both of these, we've got 2 methyl groups that are overlapping with each other, and remember they're large groups, so they're repelling each other, and that's causing this eclipsed conformation to be high in potential energy, and it's higher in potential energy than the F conformer, because if you look, nowhere in any of those eclipsed conformations you have no methyl interactions. I don't want that to be a bond, but you get the idea. Okay, this is a better way to look at it. So if you think about this as that C2-C3 bond, you don't have any of these interactions where these 2 methyl groups are eclipsed and are right on top of each other. You don't have that in F, but you do have it in B and D, and that's why they're slightly higher energy conformers than F. But as you can see here, that all the eclipsed are all the maximums, they're all the highest energies, and all the staggered conformers are all the lower energies. And that's the key thing. Build a model.